Hello and welcome. In this video tutorial, we're going to be looking at the assignment speed problems. Now in this assignment, we have a few problems to work out. Please use my tutorial as a template for how you can try and attempt your problems. Remember, you'll have different values than I do. Put your name in the program and let's begin. Now, you're going to be prompted to find the time of a moving car as soon as you hit the on button. Okay? You're going to need to then calculate the speed in meters per second, miles per hour, and then kilometers per second. So the first thing we're going to do is calculate in meters per second. Okay? Let's go ahead and press the on button, and I'll go ahead and time my car. You go ahead and time your car that it takes to travel 100 meters. Now you're going to press the start when the front end of the car hits 0. Okay, just give it a second, it'll start on its own. There we go. Oh, mine's moving very slow. Okay. And when the front end of your car hits 100 meters, go ahead and press the stop button, which is the same as the start button. Okay, now mine didn't stop, but it was around 27 seconds. So I'm gonna kind of gear it at that. Now my speed, to find my speed, okay, my equation for that would be distance divided by time. So I'd go 100 meters divided by, I'm gonna say around 27 seconds. Try and be as exact as you can. I was not very good with mine. Let's see if it gives me a good value though. Okay, so now for me, I'm getting about 3.70 meters per second. Okay, now in this particular lesson here, you also have to convert between meters per second, miles per hour, and kilometers per hour. So let's go ahead and list the values that we have. So for step 3, you're going to convert from meters per second to kilometers per hour. So note that 1 meter per second, this is the conversion factor for it, is equal to 2.237 miles per hour. Now you can write miles per hour as mph, or sometimes you'll see me write it mi/h, miles per hour. Okay, so just note that we'll kind of go back and forth with that. Now for step 4, when we get there, 1 meter per second is going to be 3.6 kilometers per hour. Okay, so we're done with the physics equation. Now we're going to use what's called dimensional analysis. That means unit conversion. So we start with our value, okay, which is 3.7. Start there. The unit. Now I know meters per second is technically 2 units, like this, top and bottom, but we're actually in this case going to treat it as one cancelable unit. So I'm going to write it all together, meters per second. Then I'm going to multiply by a conversion factor. Well, my conversion factor is going from meters per second to miles per hour. Now, you always take the unit you're trying to get rid of and you copy it diagonally down here. So I'm going to copy down meters per second here, and I'm going to miles per hour, so I'll write that up here. Now, the number you see next to meters per second, in this case 1, in the conversion factor, goes next to meters per second. The number you see next to miles per hour, which in this case is 2.237, goes next to miles per hour. At this point, the math takes care of itself because you can see you're just multiplying those 2 numbers right there. And that's why we set it up this way, so that the proper units, the units you're trying to get rid of, cancel, and you arrive at the unit that you want, which is the case of miles per hour. Go ahead and pause the video and take some time to convert your speed from meters per second to miles per hour while I convert mine. Okay, so I'm getting about 8.28 miles per hour. Now we're going to do the exact same thing. We're going to go 3.7 meters per second. But this time I'm going from meters per second to kilometers per hour. So I'll write meters per second down here, kilometers per hour up here, cancels, cancels. You can see next to meters per second is 1, next to kilometers per hour is 3.6. So mathematically, you all should be able to see that I'm just going to multiply 3.7 times 3.6. Okay, go ahead and take some time to calculate your speed in kilometers per hour. Mine comes out to about 13.3 kilometers per hour. Last step is just enter your values into the program. Okay, there you go. So apparently my actual time was 27.78, but you could see it was close enough to get me a pretty close predicted speed of 3.7. My actual speed was 3.6. So the closer you are to measuring, tapping on my screen was probably a little light. I think you'll probably have better success on your computer. But as you can see, if you get the meters per second speed right, the other two speeds are just a fairly simple conversion from meters per second to miles per hour, and then later to kilometers per hour. I hope you were able to get your question right as well. On to speed problems, question number 2. Speed of Pac-Man on x-axis. Okay, read with me together. In this program, you will be determining the speed of Pac-Man as he travels along the x-axis. You will decide when to start and stop timing to get the most accurate value you can for the speed of the object. That means Pac-Man. Don't worry if you wait too long to start your timer, since Pac-Man will return to the left side of your screen as he moves off of the right side of your screen. When finished getting your speed, you'll be asked to provide it in a few different units. Okay, so put your name in the program and let's begin. Immediately you can see Pac-Man is starting. It says use the timer to determine the speed of Pac-Man as he moves along the x-axis. The greater the distance you allow him to move during your timing, the more accurate results will be. After you determine his speed in centimeters per second, convert to meters per second and kilometers per day. All right, so now this one we're gonna be separating our distance and time units into different units, because you can see we're going from centimeters to meters, seconds to minutes, and then eventually kilometers and then days. All right, so it says click to start timing. So if you click on that phrase, that will start the whole button. So what I'm gonna do, I'm just gonna wait until he kind of scrolls back around to maybe about 10, 20, somewhere around there, and then I'm gonna time at a certain distance. Just let it go a little while so that you can get a pretty accurate value. Okay, so now in my instance, if you look, the middle of Pac-Man was right at 10, and Pac-Man's mouth is at 11, okay, 11 centimeters. He finishes with his mouth at about 71. We really want to get picky here, 71.1, okay? But that's exactly where I'm starting. So I'm gonna make a dot where those beginning and end locations are. So the beginning location is at 11. The end location is at about 71.1. Okay, so to calculate the speed, I need the distance divided by the time. So the distance, right, is gonna be the difference between 11 and 71.1. So subtract them. Do the same for your values, however you stopped Pac-Man. Okay, so my distance is about 60.1. 60.1 centimeters. Now, my time is 11,550 milliseconds. Okay, so let's take a moment to examine that one. 11,550 milliseconds. If you remember your metric staircase, meters, liters, gram, and seconds are on the middle. Milli is way down here. You have to go up 1, 2, 3 stairs to get from milliseconds to seconds. That means you have to move the decimal 1, 2, 3 places to the left to get from milliseconds to seconds. So I'm going to be actually dividing by 11.550 seconds. Okay, so I've got my values. My time is 11.550 seconds. Now I can calculate my speed. So my speed is going to be 60.1 centimeters over 11.550 seconds. Go ahead and take some time to calculate yours. Okay, now I'm getting about 5.20 centimeters per second. Remember, don't put my times in here. Your times are going to correspond to when you started and stopped your Pac-Man. Now I have to convert from let me see, into meters per minute. Meters per minute? Yeah, meters per minute, and then kilometers per day. So in step 3, we're going to do both conversions. Okay, so I'm going to take my 5.20, so 5.20 centimeters per second. Now this one, in this particular problem, unlike question 1, you're going to treat these as 2 separate units. Okay, and what we'll do is we're going to convert centimeters into meters and seconds into minutes. We're going to do both of them. So it's going to take us 2 steps. So I'll multiply by 2 conversion factors. The first one I think I'm going to switch is centimeters to meters. So I'm going to copy centimeters down here. We're going from centimeters to meters. Well, there are 100 centimeters in 1 meter. Cancels. Now my unit is in meters per second. Well, in this particular example, I don't want it in meters per second. I want it in meters per minute. That's the second entry. So I got to convert from seconds to minutes. Well, just like you diagonally copied this unit down below, you are going to diagonally copy this unit up above. Anytime you do that, the units will end up canceling if you copy them on a diagonal. So I'm going to copy seconds here, and I'll copy minutes down here. There are 60 seconds to 1 minute. Cancels, cancels. If you look at your units now, you can see you're in meters per minute. Okay, now just let the math take care of itself. What does that math look like? 5.20 times 60, then divide that by 100. Go ahead and take some time to work your own problem. I'm getting about 3.12 meters per minute. And then my last entry, I need to calculate in kilometers per day. Okay, so I'm going to go .20 centimeters per second. Now for this, it's going to take me a few steps, a few conversion factors I have to multiply. Because for instance, I'll be converting from centimeters to meters, and then meters to kilometers. And then for the time scale, I'll be converting from seconds to hours, and hours to days. So it's going to take me quite a few to get this one done. Okay, but if we do it right, then the The units will cancel nice and the math will take care of itself. All right, so the first one, centimeters to meters, there's 100 to 1, cancels, cancels. Then I'm gonna go meters to kilometers. There's 1,000 meters for every 1 kilometer. So cancels, cancels. Now I'm in kilometers per second. Okay, now I'm gonna focus on the time conversion. I'll just give it a different color just to help out. So now I'm gonna go from seconds to hours. Well, remember, there are 60 seconds in 1 minute, and there are 60 minutes in 1 hour. 60 times 60 is 3,600. So there are 3,600 seconds in 1 hour. And then last step would be hours to days, and there are, of course, 24 hours in 1 day. Okay, now let's get this all organized here. What I will end up doing is I will be multiplying 5.20 times 3,600 times 24. And then I'll be dividing that by 100 times 1,000 is what, 100,000? Okay, so I'll be dividing that by 100,000. So go ahead and take time to do your problem, and then we'll put our numbers into the program. Okay, I'm getting 4.49 kilometers per day. Now in step 4, we're not doing step 5, but in step 4, would you expect to get a smaller percent error if your speeds, for your speeds, if you allow Pac-Man to travel a larger distance like 80 as opposed to short distance by 8? Well, here's the thing. Yes, you would expect a smaller percent error. So larger distances will help with a smaller percent error because it is easier to start and stop the stopwatch. Think about it this way. Your ability to start and stop a stopwatch is based on human reaction time, okay? If you allow for greater distances, it allows you the opportunity to react to something and then start and stop the stopwatch, more accurately. If you deal with shorter distances, like 5, 10 centimeters, then you're requiring a much faster reaction time to be able to take that data. So yeah, longer distances do help. Anyway, let's go ahead and check. And there you go. All right, I hope you were able to get this one correct as well. And I hope this tutorial was helpful on your speed problems. Thank you. See you next time.